All right, Panthers, math maniacs, here we go with dividing fractions part 2. Without further ado, 24 divided by 808. Oh, here we go. 24 divided by 108. Remember, we're going to divide it by 1 because this here, 2 divided by 2, we're going to divide the top by 2 and divide the bottom by 2. But really what we're really doing here is dividing by the number 1. That's a beautiful one if I ever saw one. Get it? If I ever saw one? Okay, so if we divide 24 over 108 by 1, we're still going to get 24 over 108. So what we're saying is that 24 over 108, or 24 108ths, there we go, 24 108ths is equal to 12 54ths. Let's divide by 1 again and reduce, or lowest terms, lower the terms. We're going to get lower terms. Can we go lower? How low can you go? We're going to do the simplest terms, fraction limbo. How low can you go? Can we go lower? Yes. Let's divide that by 1 again using 2 over 2. Because really that's what we're saying, that this is 2 over 2. Yeah. Divide the top by 2, divide the bottom by 2. Can we do it again? No, not by 2 though. We can still divide by 1. But what form of 1 are we going to use this time? It can't be a 2. It can be, what's the next number? You guessed it, 3. Same thing as dividing. So by 1, which gives us the equivalent fraction of 2/9. It's equivalent, but it's in a lower terms. Lower terms, 2 and 9. 2 is less than 6. 9 is less than 27. Yeah. Let's simplify. Now, how could you do that? Same thing, but without doing so many steps. Can you do it in less steps? Kind of. If you know what the factors 24 are, and you can get the factors 108, what is the greatest common? Well, they have 1 in common, 2 in common, 3, 4, 6. They had a lot in common. Wow, they get along so nicely. I bet if they were to play, they'd be good playmates. It looks like the greatest one is 12. So what if we just started with dividing by 12 over 12? Which is the same thing as 1. Remember, here's our 1. This is really 1. 12 over 12. Divide the top by 12, 2. Divide the bottom by 12, 9. Oh, that's pretty good if you know a factor. Get your greatest common factors. It's useful in this case. Greatest common factor here. You try it and then stop the video and see what happens and come back when you're done and see how you did. All right, welcome back. Let's go. So we got, let's see, if we divide the top by 2, divide the bottom by 2, see, that's 4 over 6. Can we divide by 2 again? I think so. Divide the top by 2, divide the bottom by 2, equals 2. 6 divided by 2 is 3. There it is. So 2/3. 8/12 is equal to 2/3. Can you do it faster? Well, what's the greatest common factor between 8 and 12? Let's see if this is going to work on here. Oh, come on. You're not going to work. I have to press this lasso in order to erase. Here we go. Can I just cut that somehow faster? Okay, so let's see, greatest common factor. What are the factors of 8? 1 times 8, so I know 8 is going to be 1 times 8 is 8. 2 times 4 is 8. That's it. 1 and 12. 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. 1 times 12 is 12. 2 times 6 is 12, and 3 times 4 is 12. What's the greatest common factor? It could be 1, could be 2, not 3 though, and 4. It looks like 4. 4 is the winner. So let's just divide this by 4 over 4, which is the same thing as dividing by 1, which really gives us equivalent value. The equivalent value of 8 over 12 in lower terms is 2. 8 divided by 4 is 2, and 12 divided by 4 is 3. 2/3. Let's go. There it is. How do we do that here, though, with a mixed number? Well, with a mixed number, we're going to keep the integer here, in this case, is going to stay at 2. What about our fraction, 2/4? 2/4. What can we divide 2/4 by? Same number on the top, same number on the bottom, so it's really divided by 1, keeping it equivalent value. That's going to make this small, so we can do 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Some of you just already know 2/4 is 1/2, but if you don't, this is how another way you can get it. And it definitely comes in handy using this method when you're trying to get bigger numbers reduced down or simplified down to simpler terms as a fraction in simpler terms, lower numerator, lower denominator, but still equivalent. Yes, okay. By that, in case you didn't catch the first video, let's just see here really quick. If we take a pie, right, and well, that's not the best pie ever. I don't need the best pie ever, but I don't want it to be that bad. Divided into fourths. 1/4, 2/4, right? Let's do the color really quick. One fourth and another fourth. That's a total of 2/4, which is really the same thing as 1/2. Equivalent fractions, we just talked about that. Here's some more examples. How do we write this? Same value. This is 1/2. This is also 1/2, but you could also write it as 1/4 plus 1/4. 2/4. This is also 1/2, but you could also write it as 1, 2, 3, 4. There's a total of 5, 6, 7, 8. So they're each 1/8. So 1/8 plus 1/8 plus 1/8 plus 1/8 equals 1, 2, 3, 4/8. And you can go backwards by. So if we go this way, we really multiply. What are we multiplying by here? If we go 1, multiply 1/2, what do we multiply 1 by to get 2? 2. So whatever you do on the top, you do on the bottom. 1 times 2 is 2. 2 times 2 is 4. What do we multiply here by? Remember that 1? Oh, I love this. This is like my favorite thing ever. Did I tell you that? That this whole fraction 1 thing equivalent to 1 is like my favorite thing ever? One of my favorite things ever. So 2 times something gives you 4. 2 times 2 gives you 4. Whatever you do on the top, you do on the bottom because you got to make it 1. 4 times 2 is 8. So what if we want to go the other way? What if we want to make our numbers lower terms? Let's pick a different color. Let's pick this like really nice kind of almost teal blue kind of thing here. We do the opposite. If we multiply to get there, now we're going to divide to go backwards. 4 divided by 2 is 2. 8 divided by 2 is 4. Now we have lower terms. Can we get any lower? How low can you go? Let's do the lowest terms fraction simplified limbo. How do we go? See, 2 divided by 2 is 1. That's a lower term. 4 divided by 2 is 2. There's our lowest terms. Is this our greatest terms? 4/8? No. There's no such thing as greatest terms because you can just get greater and 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 greater up to infinity over infinity. But the numerator won't be the same infinity as the bottom infinity. They'll have different infinities. Reciprocal. That's just a fancy way of saying flip it, right? But what does that mean? How do we get that and why does it work? That's because a number when multiplied by a given number results in the product. Oh, there's my number 1. Who's number 1? You're number 1. I'm number 1. Wait, there can't be 2 number 1s. One of us has got to go. Or one of us got to go down. The other one's got to, no. Do you really have to blow out somebody else's candle so yours burns brighter? I don't think so. You can make yours burn brighter without having to blow out somebody else's candle. So we could both be, can we both be number 1? We'll work on that later. In the meantime, let's go. How many of these halves, you got half a circle here, how many of these will it take to make a whole circle? Well, right here, you put half together with another half, you get a whole. Okay, so we need 2 half circles to make a whole. So 2 times 1/2 equals 1. So the reciprocal of 2 is 1/2. What's the reciprocal of 1/2? 2. You just flip them. Now remember, you can rewrite a whole number, which I don't think we got into this yet. You could rewrite a whole number as a fraction. How would you do that? 2 over 1. Because really that's the same thing as saying 2 divided by 1. 2 divided by 1 is 2. So how would you rewrite the fraction 3, or the whole number 3 as a fraction? 3 over 1. What about 4? 4 over 1. What about 3,271? Well, that would be 3,271 over 1. Same thing, they're equal. So what's you put a 1 over this, you're just flipping them. There's flip it, remember? Put a 1 over this, you're just flipping them. The reciprocal is flipping. Yeah, the reciprocal is flipping. How about 1/4? How many 1/4 does it take to make a whole 1? It takes 1, 2, 3, 4. So 4 times 1/4 is 1. So the reciprocal of 4, or 4 over 1, is 1/4. Flip them. The reciprocal of 1/4 is 4 over 1, or 4. Flip them. Your turn. Stop the video and see if you could find the reciprocals of the following. All right, you're back. Let's see how you did. 5 over 8, you flip it, 8 over 5. 6 over 5, you flip it, 5 over 6. 8, uh-oh, what are we flipping? Oh, remember, that's really 8 over 1, so that's 1 over 8. What's the reciprocal of 3/4? 4/3. 11/3. 3/11. 5, uh-oh. Yep, same thing as 5 over 1, 1/5. So how are we doing on following our targets so far today? Can you divide fractions? Do you remember this problem? Well, what are we going to do here? It should be as easy as pi, right? Dividing fractions as easy as pi. Flip the second and multiply. Let's do this. So this should be pretty easy. 2 3/4. 3 over 1. I just flipped it, right? I did the reciprocal times. But here's the thing. You can't just multiply a mixed number with a fraction. It doesn't work that way. You have to turn it into a fraction, like an improper fraction, also called a fraction greater than 1. All right, so that's fraction greater than 1. Because this could be a fraction greater than 1 if we do a little trick. So that trick we're going to learn about right now. So let's see, if we draw a model of this, 1 and 1/4. So I'm going to let this represent 1. So what would 1/4 of that be? Let me draw the 1 again. And let's take 1/4 of that. I'll divide it into 4ths. That means I have to draw 3 lines. Now I have 4 parts. 1/4 is this much. So I'll shade in the 1 and 1/4. All right, what about a model for 2 1/2? Very similarly, I will draw 2 beautiful, almost perfect rectangles. And I'll draw a third one, but this time I only want half. You know, I forgot to do something in the last problem, but we'll go back to that in a second. Let me get another color for the moment. Kind of defeating the whole purpose here. So what if we divided all of these in halves? How many halves do we have shaded? 1, 2, 3, 4, 5. So we have 5 halves. So 2 1/2 is the same thing as 5 halves. Now going back to this 1 and 1/4. Let's see here, 1 and 1/4. So we want to know basically how many fourths are there. I guess I should have picked a different color, but we're going to just roll with this. So if we shade in here, 1/4, 2/4, 3/4, 4/4, and then 1/4. That's it. So how many total fourths is that? That's another color. 1, 2, 3, 4, 5/4. So 1 1/4 is the same thing as 5/4. Maybe you're seeing a pattern here. See this 4? Do we have a 4 in our answer? It's at the bottom. See this 2? Do we have a 2 in our answer, our equivalent fraction that's a proper fraction or a fraction greater than 1? Yeah, so that's part of the trick when we get to bigger numbers. See, that's great drawing these models, Mr. Hoffman, but you're using small mixed numbers. What happens if you get some bigger ones, more complicated stuff? How are we going to do that? Like, for example, this one, 2 and 3, 6. How many 6 is that? So right away, we know we put the 6 on the bottom, right? That's where that comes from. So how do we get this? Let's get a different color. We got 1, 2, 3, 4, 5, 6. How many 6? 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 6. So the 15 goes on top. All right, so we know where the 6 came from, but what can we do with those other two numbers? The 2 and the 3 and the 6. Actually, we have to use all three. That gives us 15. That is the why of what we're going to be doing. Remember I said the how and the why? Here's the why. I love the why. Why do I love the why? Well, I'll get back to you on that later. But in the meantime, let's do this. Remember we said 1 and 1/4. Let's go back and look at that. We said the answer is 5/4. 5/4. Or the equivalent is 5/4. So we know where the 4 came from, but what can we do with all three of these numbers to end up with 5? What can you do with 1, 4, and 1 to get 5? How about here? What can you do with 2, 2, and 1 to get 5? 2, 2, and 1 to get 5. What operations? I mean, because if you did 4 plus 1, then we're already there. So you can't be 4 plus 1 plus 1. 2 plus 2 is 4 plus 1. Maybe if you add them all together, that might work. But will that work every time? How about here? 6 plus 2 plus 3. 6, 7, 8, 9, 10, 11. No, we need 15. You know, 6 plus 2 plus 3, 6, 7, 8, 9. That's 11. But we need it to equal 15, as it says here. So it can't be adding. Adding isn't going to work. I mean, adding could be part of it, but is it all the whole deal? Let's try another one and see if we can get it. So we know the bottom's going to be 3. The denominator, the bottom, is 3. What do we do with the 3, the 1, and the 2? The 1, the 3, and the 2, whatever, to get what we have on the top, which is how many? 1, 2, 3, 4, 5. What can we do? We can add them this time. No, we can't add. Okay, you give up? All right, I'm going to have to tell you. Say 1 times 3 plus 2. So you take the whole number, multiply it by the denominator, add the numerator. Take the whole number, multiply by the denominator, then add the numerator. 1 times 3 is 3. What's 3 plus 2? 5. Does that work every time? Let's see. 2 times 6 is 12, plus 3 is 15. 2 times 6 plus 3 is 15. It works! 2 times 2 is 4, plus 1 is 5. It is. There it goes. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4, plus 1 is 5. And on this one, 1 times 4 plus 1. 1 times 4 is 4, plus 1 is 5. All right, let's go to a big one. Without even counting, what do? 6 times 5. 6 times 5 equals 30. And whatever that answer is, add the numerator to it. So 30 plus 3 is 33. 33 what though? 33 over the denominator. Remember, that was the easy part. Your turn. Do these. Press pause and come back and see how you did. And we're back. And now I'm late for it. Boy, I mean, 3 times 3 plus 1 is 6, 7 over 3. 5 times 3 is 15, plus the 2 is 17 over 3. 6 times 5 is 30. I can write. Yes, I can. And 30 plus 3, 33 over 5. 6 times 9 is 54, plus the numerator is 57. (57) over 9. 5 times 9 is 45 plus 7. 40. Is it 45? Yeah, 45 plus 7. Now I'm going to try to do this. So I could think, I'm going to decompose because I know I can take 7 is the same thing as 5 plus 2. Now I have some friendly numbers. I know 5 goes really good with 45 and turns into 50. But what do I have left from that 7 when I decompose it? I still have to do something with the 2. So add 2, and I get 52. 52 over, and then the easy part, 9. How'd you do? That's what I thought. Excellent. All right, last part we're going to save. We're going to fly through this. Let's do this. Now, you're going to be asked to do some division with some area. So first of all, how do we find the area when you're given the length 3 units and then the width of 2 units? You just multiply. See, because this would be like 2 divided into 2, and this is divided into 3. Thirds going this way up and down. So we have a total of 1, 2, 3, 4, 5, 6. 6 square units. Or you can just say 2 times 3 is 6. What about over here? What if you're given the area is 20? So you know the inside is 20, right? But you want to figure out what this is. So you go the other way around. You take whatever the total is, and since here we did multiplication, now we're going to do the opposite, which is division. We're going to say 20 divided by 5, and that's going to give us what the width is. And we know 5 times 4 is 20, so this is going to be 4. Oh, that's all fine and dandy, but what if we take it to another level and throw some fractions in there? Okay, 1/2 times 2/3. 1 times 2 is 2. 2 times 3 is 6. So the answer is 2/6. And as you know, we could simplify that, but let's just leave it as 2/6 for now. Simplified a fraction. Simplest terms, lowest terms. Okay, what about here? Division. So now they give us the area is 5/9. So how are we going to find the width? We're going to do divide. You're going to take this number, just like we did back here. We took the inside number. My fault. Took the bigger number, larger number, greater number in this case, and divided by this one. So we better do the same thing here. Better take the 5/9. That's important because if you started with the 5/6, you're not going to get the same answer. And divide it by 5/6. And we know when we divide, it's easy as pie. You flip the second and you multiply. So let's rewrite that as 5/9 times 6/5. And we get 30 over 45. Can we simplify? Yes, but we'll just leave it there for now. So, how you feeling? Are you Jedi Master, Jedi Knight, Padawan, or Youngling? Email me your answer. All right, bye.